Hello again to all of you. So we will continue on the problem solving for generation of AC voltages. We are on problem number 7 now. So I'll read the problem first. The time domain equations representing three generators are as follows. So you have instantaneous value of E1, 46 sine 377 plus 56 degree volts. E2 equal to 51 sine 377t plus 76 degree volts, and E3 is equal to 96 cosine 377t minus 144 degree volts. We need to compute for the resultant voltage or resultant voltage. Now, before we go to the problem itself, we need to review some of the basics and summary of some of the phasor concepts. Okay, so this is being discussed to you on your circuits. Okay, we just recalling them so that you have an idea, because if you know how to deal with these fundamentals, we can easily solve problem 7. Okay, first we need to know what is an antiphasor or all about, or antiphasors. So it means we need to convert a certain antiphasor, okay, based from a certain reference. Okay, for example. Okay, for example, okay, I have a voltage here. Okay, I could say V. Okay, in phasor, we have, for example, V phasor, we have 5 bar 30 or positive 30. So if this is my reference, positive 30 means you have the angle in a counterclockwise direction on a positive 30 degree based from a certain reference. So if your reference is here, there's always reference which is bar 0. We have the 30 degree here. 30 degree, if you can see. 30 degree angle. Okay? That 30 degree angle, no, counterclockwise, positive 30, and you have 5 units. 1, 2, 3, 4, 5. And that constitutes that vector V or phasor V. However, okay, based on that vector, we need to get the antiphase of that vector. So what's the meaning of that? We need to get the antiphase, meaning the opposite of that vector. Okay, V. Okay, I could say this one is VAN, for example, means phase A up to neutral. I need to get vector VNA, which means the antiphase or opposite phase of that vector VAN rather. So we need to get VNA rather. So you need to interchange the letters. So how can you do that? Okay, that's the meaning of how to antiphase a certain vector or antiphasor. Okay, you have two solutions. You can add a plus or minus 80 at the vector or on the polar form. That's the polar form, and if you have an angle, for example, and you have a vector V, and you have V magnitude, for example, okay, so you have plus or minus 180 on the vector side. Or you can do by changing the magnitude of the sign. So it means if you have 5 here, you have positive, negative 5, no, on the opposite. So it means you change only the magnitude of the sign and not the angle. Okay, example, for this example, so we can solve this. So what is the VNA or the antiphasor of this vector? So if you use solution number 1, no, by direction, the answer here for VNA simply equal to 5 bar angle 30 plus or minus 180. You can use plus or minus 180 simply because if you use the respective reference vector V, okay, so this is, if you turn the angle in a clockwise direction, Based on a certain reference, which is I could say point O, this is negative 180. Otherwise, on the opposite side, on the counterclockwise direction, this is plus 180. So it means you concentrate on the angle side. Now, the other way is you can change only the sign. So your VNA simply equal to, if this is positive, just change the sign. So it will become negative 5, but you do not need to add plus or minus 180. So we will stick to 30. So the answer is negative 5 bar 30. So it means that, okay, that in anti-phasors, you can use bidirection only and by changing the magnitude of the sign. So this is very, very helpful in on simplifying vectors. Okay, now how can you convert cosine to sine or sine to cosine? You can use also sine to cosine. Okay, so we have here some equations here, very, very important. So what I will do is I will box this one for your reference. Okay, the omega t here means this is your angular frequency, 2 pi f, that is always constant. And as I have mentioned, if you still recall, that the difference between cosine and sine is the angle 90 degree between them. So you can have plus minus 90 here, okay, for both cosine and sine, and you have here sine and cosine. Okay, let us have the mnemonic. The mnemonic here that I usually use is to convert. To convert. Don't forget that. It means, okay, you have here cosine omega t plus minus 90 degree equals minus plus sine omega t. Please take note, it means minus or positive, no? And then sine omega t plus minus 90 degree plus minus cosine omega t. Or simply, it means if I want to convert negative sine omega t to its corresponding cosine, you need to add plus 90 degree. Please take note, minus, it corresponds to plus. Or, if you have a positive sign, I want to convert it to cosine, this is negative. Kaya nga, or in Tagalog, that is Tagalog. That's why, in English, that's why to convert negative sign to cosine, you need to add plus 90 degree. Or to convert positive sign to cosine, you need to have negative 90. Or in other words, okay, for this, okay, if I want to convert sine omega t, okay, to cosine omega t, okay, positive for example, so it means I need to, okay, positive sign to cosine, see the polarity mark, I need to minus 90 degree. This will work. This will also work if I want to convert a cosine to sine. So it means you have a positive cosine here. I want to convert to sine. You must add plus 90. Or another way around, that's negative 90. Negative cosine omega t rather. You want to convert to sine, you need to deduct, or you must have minus 90. Or in other words again, okay, cosine omega t, I want to convert, okay, to convert it to sine omega t, positive. What you will do is, okay, yes, you need to have plus 90 degree. You need to add the angle with a plus 90 degree. So that's the to convert formula. So don't forget that mnemonic. And last but not the least, Before you have phasor operations, first you must have the same function. So it means sine and cosine, all the function must be sine or cosine, all of them. If you want to add, you have to subtract, you want to divide. When you say operations, you have plus, minus, divide, and multiply, right? Okay, now if you want to have a operation on phasor, it must have the same function, but we usually use the sine function, okay, instead of the cosine, because it is much better to use sine, because purely in a power system, a bigger power system already has more reactive elements rather than real elements. And you must have the same frequency or angular velocity, which is, in other words, it is 2 pi f. So we can now solve this problem on the next slide. Thank you. Okay, hello. Let's conclude our last problem, which is problem number 7 from the last slide that we already described or discussed the concepts and fundamentals. Okay, let's move to the solution proper. We already read the problem, so we need to get the resultant E, or the resultant voltage at this terminal, and given 3 generators connected in series, sinusoidal with respect to time, so there are in terms of sinusoids. Okay, this is the given, no? Based on the problem, we have E1 46 sine 377t plus 56 degree, E2 51 sine 377t plus 76 degree, and last but not the least, E3 96 cosine 377t minus 144. So to get the resultant, you need to get the vector E or phasor E by adding all of the voltages. As you can recall in KBL, considering again the polarity marks, if you have the loop here, the total voltage E is just the summation of all of the voltages around the loop, which is E is equal to E1 plus E2 plus E3, which is here based on this equation. Okay, thus, before we proceed with anything else, if you can still recall from the last slide, we need to check the parameters before you add, you subtract, you divide, you multiply. We need to check the phasor first. If they have the same angular velocity or frequency, yes. Because the frequency here is matic 60 Hertz from 2 pi 60. Because of 377 here. Okay, check. Now, the function is not the same. You need to have the same function, cosine to cosine, cosine and sine. So, since you have here sine, and we need to do this already, that we must have the same function, which is sine, we need to convert cosine. So, that's why we have the basic fundamental on how to convert cosine to sine and sine to cosine, respectively. Okay, now, if you can still also recall, that we can already, okay, convert any time function to its phasor. You can still recall, okay? So if you can still recall, okay, for this, recall, okay, that you have EM here, okay, and then you sin omega t plus minus the angle can be converted to a phasor E, but it must be E here, must be in RMS, then the bar angle plus or minus angle theta. Please take note, it must be in RMS form. So it's pretty clear here is the maximum value. To get the RMS, you need to divide by square root of 2. So that's why it becomes 46 over square root of 2, because this is the maximum value. Okay? And then the bar angle plus 56. Okay, check. E2, 51 over square root of 2. 76 degree, check. But our problem here is the cosine. We need to convert it to sine. So that's why it's ready look spam. To convert cosine to sine positive, you need to add 90 degree on the angle displacement. So that's why you have a plus 90 here. So by adding plus and minus 144, 90 minus 140 is negative 54, and you divide 96 by square root of 2. And last but not the least, you need to add These three, because you have the same frequency, same function already by sine, and the answer here is 67.18 bar angle 6.013 degree volts. So again, you already have a fully understanding of what we have discussed so far from the basics up to this problem. And now we can go forward to the next few problems. Hello, once again. Now we will solve problem number 8. And before we do that, if you want to know the problems, the list of problems or the main problems, the supplementary problems is you can see it on the link at the description page of this video, and that link will be you will be transferred to a Google Drive sheet or in Mapua Google Sheets, so you can see the problems there, so you can practice that out, the supplementary problems, and the wording problems that we are already discussing here are already there. Okay, plus if you have some questions or comments, you can go to the comment section, and then you can have your questions there at the comment section of this video. Now let us solve this problem here. So this is the problem. I read it again. No, the current is represented by an equation which is 10 sine omega t plus 30 degree, then plus sine 3 omega t minus 30 degree. The magnitudes of the components are instantaneous values. Now the question is, what is the RMS value of the current? Okay, before we attack the problem, we from the previous problem, we need to check if the problem is have the same frequency and then same function. So this is are the categories if you want to solve Pacor problems. But in this case, it's very evident that this problem does not have the same frequency, simply because this is omega t and this is 3 omega t. So you are considering now an harmonic frequency at the odd case sequence. But you have the same function, yes, because you have the same sine function. Okay, so how can you solve this problem since they have different frequency? So there's a way here if you know the superposition theorem, but a much better solution here is using the root mean square equation, which is this equation here. So the square root of the magnitude of the RMS of the first function, the RMS of the second function, third function, then you need to square it. But please take note that if you have a DC component, you need to square it. So what's the meaning of that? So for example, this problem has a DC component, for example, plus 100. There is no sinusoidal waveform because this one is a sinusoid or instantaneous value. But this one, if there's no sine or cosine, so it's not an instantaneous value. But if this is only 100, you're considering this a DC. So if that is a DC signal, then you need to square the 100, then include it on the calculation. Okay, however, in our problem, no, we do not have that, so we can have a straightforward solution. And please take note, this is already, okay, a maximum value. So if you can still recall the RMS, typical RMS value, you need to divide the maximum value by square root of 2. Okay, by doing so, yes, it's a straightforward solution. 10 over square root of 2 plus 5 over square root of 2. Then you squared both magnitudes. The answer for this problem is a very, very simple problem. If you know the RMS value, formula for an harmonic frequency of odd sequence, the answer is 7.9. By the way, before we proceed, this is a non-sinusoidal waveform, to be exact. Non-sinusoidal. So you expect the sinusoid It's not a perfect, but like this. Okay, because you have frequencies or harmonic frequencies. Okay, let's continue with another problem. Okay, this is problem number 9, so I will read the problem again. The average value of a certain function is equal to what? No, I is equal, the signal is I is equal to 50 sine omega t plus 20 sine 3 omega t is equal to, okay, so the question here at problem number 9 is you need to get the average function of that current signal, which is equal to 50 sine omega t plus 20 sine 3 omega t. Okay, again, let us check if we can solve it by phasor method. So, you need to have the same frequency, same function. Okay, they have the same function, very clear. You have sine and sine. But, however, you do not have the same angular frequency. So, again, we will need to make use of another important equation, getting the average for a non-sinusoidal waveform with an odd harmonic frequency sequence. So, in this case, well, we have the I average, which is equal to 2 all over pi. This already looks fun because 2 all over pi is 0.637 from our previous discussion. And then of the maximum value of the first function, second function, third function in terms of the harmonics. So you need to divide it by 1, 3, and 5 in terms of the odd. Okay, since our problem is already automatic that 50 and 20 is in the instantaneous value side, so 50 and 20 are maximum value, you do not need to divide it by square root of 2, because if you do that, the value becomes root mean square. So, just input the variables in this formula, which is I average 2 all over pi, then multiply by 50 over 1 plus 20 over 3. The answer in this problem, a very, very simple problem, is 36.1 amperes. So we will continue our discussion on RLC, RL and RC series and parallel circuits. So we will solve some simple problems on these topics. Thank you.